So we will continue further with some of these examples. Okay, and all of the organic families that you see up there are what? Each and every one of them is a what? With the exception of the top, the very top. That's a real, yeah, they are all alkenes. And we know that. Why or how? They're all single bonds, and roughly the single bonds is probably the best to look at that. Even though that second one down has a halogen on it, therefore it's a halogen derivative. Some of these are pretty tricky, and that's why we want to work on these together. So that's why we have this book in front of us, and I want you to. And what's going to happen, you'll notice the title on here, it says General Organic and Biochemistry. So for those of you who do take this in college, chances are you might get a book similar to this, and you may do some review with general chemistry. Not likely, but it is possible. But chances are you go straight from the general or inorganic class to an organic type. So what we want you to do is turn to page. Where are these? Okay, page 309. Okay. So as we look on page 309, it gives you the different aspects that we want you to go through and place in these orders so we name them correctly. Okay. So on page 308, it's just talking about the international unit or physical and applied chemist. That's what the IUPAC stands for, I believe. But anyway, when we look at page 309, it says the name of the longest continuous chain becomes the base or the parent's name. That's nothing new. We've been doing that when you were a freshman. We did that last year when you were a junior, and we continue on with that as seniors. Okay? The suffix ending of the family name is added to the end of this base name, and we've done that with your organic families. If you had a double bonded oxygen on the first carbon, we say, and there's 3 of them, we don't say it's propane anymore. We change the suffix to al because it's an aldehyde, so it would be known as propanal then. So we're talking about the same thing here. The suffix is ane. Note that if the subsequent rules are correctly applied, a failure to correctly identify the longest continuous chain will result in an incorrect name for that compound. Okay? And chances are it might be a derivative, but it's not the parent chain that we would want you to know. Okay? So you've been applying these rules, you just never knew what they were specifically. Just like, for instance, if I was to, again, go to a volleyball match, I know I get mixed up on what a touch is as far as a block, and think, well, that was 4 hits. Well, when you're going up to block and you touch it, that don't count. See, I don't know the rules that well, so I sometimes think, well, that was 4 hits. Okay, so the same type of analogy there. Okay, so number 2. Base name accounts only for the carbons in the longest continuous chain. The carbons that are not part of the longest continuous chain, those attached as branches to the longest continuous chain are called substituents. I like derivatives better. I believe is a better name, or groups. Also must be included a name. Substituents or /derivatives are included as follows. So when we're talking about these derivatives, we know that this is your parent chain right here. Okay, so that's how we would get your name. And when we do that, 1, 2, 3, 4, 5, 6, it's an alkane, so we know the parent name for this compound is what? It's going to be hexane because we already established it's all single bonded, so it's an alkane. The prefix for 6 is HEX, so that's where the term hexane comes from. Okay. Now, we move on to letter 2A. The names of an alkyl group in a compound is placed in front of the base name, and we've been doing that too. On your papers, you might have had 2-methylpentane, something to that effect. That's what 2A is talking about. Okay. Then in 2B, use the prefixes di, tri, tetra, penta, and hexa. We really don't get that big. We might get up to tetra. That's about it. Because when you have 2, if these are 2 methyl groups, what prefix would you put in front of those methyl groups? The prefix di, meaning 2. Should this be another methyl group, then of course it would be tri for 3 of them. Okay. 2C. Then finally, alphabetize. Letter 2C. It says alphabetize the names of the alkyl groups when there are 2 or more different types of groups. Ignore all prefixes. That trips students up a lot. Okay. You ignore the prefixes, but oddly enough, it's going to say there's always going to be an exception. Okay. Now, alphabetize these groups when there are 2 or more different types of groups. Ignore all prefixes like secondary. That's what S is. T for tertiary. The same thing would be di and tri. You would also ignore those. In alphabetizing, with one exception, okay? And that is if it's iso.
I call it Kayla.
Sure.
I was like, no. No, go ahead. I'm sorry, Rob.
Okay. So again, that iso or ISO that it's referring to would be isopropyl or isobutyl. Okay. So then you don't go by the B in butyl or the P in propyl. You go by the letter I because it's an exception. Why that is, I don't have an answer for. That's just what this IUPAC system, a group of applied chemists just said, well, we're going to leave out isopropyl as an exception. And that's these 2 examples that you see here, and we'll get to that a little later. Okay. And then finally, number 3, number the carbons in the longest continuous chain starting from whichever end will result in the lowest number. That's why we say think golf or think cross country, because you want the lowest score. Okay? And finally, number 4, in front of the name of each alkyl group, place the number of the carbon. Then it says use hyphens to separate numbers from words. Use commas to separate numbers. Okay, now that was a lot of information in a short amount of time, but you've been applying that for the better part of, I would say, 2 months when you put together your freshman experience with your junior experience. Okay, so let's go ahead and name this. We already established there are 6 carbons, and it's an alkane. So we know this is what parent name. Hex in the family is alkane. So that's how we get or arrive at hexane. Okay. So again, this tells us our family, that's an alkane. This tells us how many carbons are in that alkane chain. Next, we need to see, is there anything branching off of that hexane? And of course, the answer is yes. So where are those derivatives located? Okay. So the next thing that we would have to establish, are we going to go right to left? That would give us 3, 4, and 5. Okay. So 3, 4, and 5. Or are we going right to left, which would result in 2, like you had correctly said, 2, 3, and 4. So it's the bottom set of numbers that gives you the lower combination. Okay. Then the final aspect, once you've named your family, named how many carbons are in your parent chain, then what do we got to do with these 2, 3s, and 4s? It's telling you that something is branching off of there. So where do we start? Remember, it's got to be alphabetically. So what comes first? What type of derivative is this one? The chloral, so we can put a C just for chloral. And what's this derivative? M, and this one? Okay, so we know we've got derivatives on 2, 3, and 4. And alphabetically, this one comes first. So this is on which carbon then? 2. You're going to want to always leave a lot of space. I'm going to write really small. So remember, dashes or hyphens separate numbers from words. So we got 2 dash what? Chloral. Okay. Then we're separating a word from a letter. So we got dash. So what do you think would come next? Okay, exactly. So we want 3, and commas separate numbers. 3, comma 4. Then we got a word, dash dimethyl. Hexane. Now, what's true about this word? Alphabetically, what do you go by? According to the rules. Not the die. Okay? You go by the group, with the exception of ISO. Okay, so this is named correctly. 2 chloral, 3, 4 dimethylhexane.
So that other carbon was like on the one that's branching off. That was down by the other one, like branching off the other one.
This one here?
No,
The one that's already branching off?
Yeah.
So like the number 4.
Like the fourth one.
This one here.
What if it was branching off of the methyl?
Oh, down here?
Yeah.
Yeah.
Oh, well then it would be an
That's
ethyl group. Then you have a 2 carbon derivative. Okay. Is anybody lost? Okay. So now you tell me what color: purple, orange, green, or whatever. That's pink or red. You tell me what to do next.
purple.
Okay. So with that, what's your longest continuous chain? Okay. So we're going to say octane. I think that's right. 1, 2, 3, 4, 5, 6, 7, 8. And just to double check, 1, 2, 3, 4, 5, 6, 7, 8. We really don't know what to call that. Okay, if we go that up and over, but just maybe to make it a little more concrete, I'm just going to pick this up, move him over, and it'll make even more sense. I want to put him down here. There. There we go. Then 1, 2, 3, 4, 5, 6, 7. Okay, now it'll make a little more sense. Okay? You picked a hard one. Because now, as you look at page 308, that tells you all the different derivatives that you will be responsible for. Remember, when you were a freshman, you needed to know methyl group and ethyl. Then, when you were a junior, you needed to know methyl, ethyl, propyl, and then the fourth one down is what? Isopropyl. So look at the structure, okay? What it's saying is where we say X marks the spot, okay, on that carbon, notice you see the same structure in the next column where it says expanded structural formula. You see the exact same structures you see in your book. So when you see this, we want you to recognize this as isopropyl. Okay? So what carbon is that isopropyl group branching off of? The fourth one. So we would go 4 dash isopropyl. Okay. But then what would happen if we put this guy here? Okay. What type of group is that? That's a methyl group. Okay. So that still would come after this because we go by the I. Okay. But if we put an ethyl group on there, then it's a little different. This is where it gets to be a little confusing. You might look, oh, I have to ignore prefixes. Here we got a P, here we have an E. Which one comes first? It's actually still this one instead. You don't want to say, well, this comes second, but you go by the I, not the P.
So then if you were to change it, so it's not isopropyl, it's just a propyl.
Okay, then, guys, okay, so then a propyl group would just all be linear. Just like that. That would just be a propyl group then. And this is where it's going to be a little taxing on yourself. When you look at page 308, what do you see below isopropyl? You see butyl, you see secondary butyl, you see isobutyl, and you see tertiary butyl. You will be responsible for all of those. Okay? That's why we want to take it in a slow progression. Freshman year, you need to know 2. Junior year, you needed to know 3. Now, we like this class so much, you need to know, what is it, 6? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them to be responsible for. Okay. Any questions on this purple one, the octane? Okay. What color's next? You have green, orange, or whatever that is. Okay. So find your parent chain first. Okay. Everything's single bonded, so it is hexane. Okay. Is there anything, of course, there's a couple of derivatives branching off of that hexane. What do you think they are? There's a methyl group and an ethyl group. Okay. Now, what that means is that you can write out, this is the molecular formula. There's nothing wrong with just saying, I would rather see this instead. Okay? These mean the exact same things, because you notice you have 2 carbons, right? 5 hydrogens, 2 and 3. So, should you do that, that's fine, but then just make sure you put a line through that or erase it. These 2 mean the exact same thing. They are both ethyl groups. Are we good with that? Okay, C2H5, that is an ethyl group. Okay, we'll just erase him. Then you might think, well, what about if it branches like this? Well, let's see. 1, 2, 3, 4, 5, 6. It's still 6 carbons. Okay, so we got hexane. Now we've got an ethyl group, like you said, and a methyl group. So we've got me. So how does me go? What comes first? The ethyl comes first, even though it's got a what number? It's got a bigger number, but it still comes first because this comes before that. So are we going left to right or right to left? Right to left. This ethyl group is on which carbon then? On the 4th one. So we've got 4, then what? Dash ethyl dash. Okay, and that's it. This is saying trainers. This is saying we've got all single bonds. That's true. This is saying we've got 6 carbons in our parent chain, which we do. This is saying there's a methyl group somewhere. That methyl group is located on the 2nd carbon. There it is. This is saying there's an ethyl group on there, and it's telling you it's on the 4th carbon, and there it is. Okay, I want to give you the rest of the time. We will continue with those 2 tomorrow. Is there any concerns on the paper that is due tomorrow? Want to go over some of those names, and hopefully we covered enough to get you over that hump, because there is a ring structure. You can just put the books back on the shelf, or you can take them with you should you feel the need. And also on the inside cover, or the back cover, I can't remember which, there's a quick guide to all of the organic. It's on the inside back cover. It shows you a guide of all the different organic families that you would be responsible. Barring no questions, left outside, are we good? Middle, are we good? Right, are we good? All right, we will continue with this tomorrow.